Hello, everyone. Welcome for joining us for the second part of our webinar series, Contamination Control Success in the Mining Industry, Part 2. Thanks to our distribution partner, Filtration Management Solutions, we are able to share with you a great success story in the mining industry. Thank you, Wesley and Martijn, for hosting. Wesley Boykes is a regional manager for Filtration Management Solutions based in Johannesburg, South Africa. With a strong background as a qualified diesel mechanic and extensive experience in hydraulics, Wesley has built his career around improving the reliability and efficiency of critical equipment. Over the years, Wesley has worked with a wide range of industries to identify root causes of contamination, implement best practices, and deliver measurable improvements in machine performance and uptime. Martijn de Jager is the Regional Sales Manager for Middle East and Africa and RMF Systems Business Development Manager at Desccase. At Desccase, he spent the last 7 years driving sales, delivering training, and conducting plant assessments to help clients achieve lubrication excellence. Prior to Desccase, he spent 10 years performing API 653 inspections for above-ground storage tanks worldwide, gaining extensive experience in inspection and compliance. With that, I hand it over to Martijn and Wesley.
Hi, friend. Thank you very much for that introduction. We'd like to just welcome everybody. It's great to have you all here, and I see we have people joining from all different parts in the world. And that's always exciting. You know, it shows that it just shows how the global conversation around reliability and contamination control has become very, very popular. Good, thank you. So let's start with some context about the operation. So this chrome smelter runs on a capacity of about 240,000 tons of ferrochrome per annum, using 2 large enclosed furnaces. So before anything reaches those furnaces, the pelletizing and sintering plant plays a critical role. So what they do is they take the chrome ore fines, the material that would otherwise be inefficient or even unusable, and it turns it into a strong, porous, sintered pellets. So why does this matter? Well, because it gives the furnace a constant high-quality feed. It improves the gas flow and the smelting stability, reduces the energy consumption per ton of ferrochrome produced, and it also increases the chrome recovery, meaning more of the valuable metal ends up in the final product instead of it being lost to the slag on top of the melted material. So it also has environmental and operational benefits. There's less dust excuse me, and material losses during handling, lower slag volumes and waste, potentially reduced emissions thanks to the more efficient furnace performance. So that is how our story begins. So at FMS, Filtration Management Solutions, we reached out to the smelt to introduce ourselves. You know, it was nothing formal, just a conversation about what we are and what we specialize in, and that being contamination control, and by implementing ICML best practice lubrication standards. So that simple conversation opened the door. Now, the other end of that door was the engineering manager, who immediately pointed to one of the plant's biggest pain points, and that is the steel belt gearboxes. So he told us straight that these are very critical assets. You know, the cost, the lead times, and the production risk if one fails is massive. And just like that, we were on site to have a closer look. So our next step was to understand the challenge. And here's what we found. So the steel belt gearboxes are truly critical assets. They're high value components with reported lead times of 52 weeks. So that's an entire year if one fails and you do not have a spare unit in stock. So a failure here isn't just, you know, a maintenance headache. It poses a major production risk for the entire smelter. So when we looked at the oil samples reports, the problem actually became very clear. We saw very high where metals, especially iron, were showing up on those oil analysis reports consistently. The existing filtration units that they had installed simply were not keeping up with the contamination ingress. And the cost of doing nothing, was significant. Each gearbox holds 105 liters of ISO VG320. It's a polyalpha olefin synthetic. And oil changeouts were happening, they were telling us every 3 months or every quarter. So those changeouts were very expensive and disruptive, yet they were not really solving the root cause of the wear forming within the gearbox. So we had a classic reliability problem. The asset was critical, it was high risk, it's high cost, no effective contamination control in place. So we teamed up with RMF Systems and Desiccant to engineer, better solutions, something smarter, something more dedicated. And I'll let Martijn explain the solution to you a little bit better.
Yeah, thank you for that, Wesley. Yeah, so during the conversations we had with FMS and client, we looked at all the aspects related to lubrication, where contamination and condition monitoring stuck out the most, of course. And this is in the end quite logical as per what we've seen during part 1 of the webinar series. Approximately 80% of the gearbox failures are lubrication related, and 1 in every 4 failures is directly caused by contamination. What we also discovered was that the temporarily installed filtration system was not bringing down the contamination levels. So we had to ask ourselves an important question. How can we achieve a balanced contamination control strategy for this application? We went to work and came up with a superb solution. With respect to the condition monitoring, previously the end user was taking manual samples every month. Adding a week or 2 to get the results back from the lab means that they had to wait for like 5 to 6 weeks to get a report. You can imagine that for process critical equipment operating in harsh environments like this, a lot can suddenly happen when it comes to functional and or catastrophic failures. And therefore they wanted to move to continuous monitoring. Our solution, as you can see here, a customized, compact, smart offline filtration and condition monitoring system designed to work 24/7, microfiltering the oil and continuous monitoring the oil. Now, before we dive into a little bit more into the filtration solution, it's important to remember and realize that high-value large gearboxes are designed and manufactured to at least last for 25 to 30 years, or even have an infinite service life, as some OEMs state. However, what we see in practice, especially in harsh environments and challenging process conditions, is that they break down after 5 to 10 years, or even sooner. This significant reduction of service life, as we often see in the field, is related to contamination. In this particular case, the gearboxes are running on an oil with an ISO class of 23-22-19, which is highly contaminated. And we come across this actually on a regular basis in multiple different industries. But considering the target of 18, 15, 12, as we've seen in part 1, it makes perfect sense that the previous gearbox only lasted for 15 years before it had a catastrophic failure. And note that this is only half of the equipment design life. Having this said, let's go back to our solution. Well, first of all, we looked at the lubricant itself, the type, viscosity, and operating temperature. As the main gearbox in this application turned very slow, the temperature of the oil, thus also the viscosity, was dependent on the fluctuating ambient temperature, which could fluctuate from 10 degrees Celsius in the winter to approximately 30 Celsius in the summer. To smooth out these fluctuations and to increase the lubricity and the filterability of the oil, we decided to install a heater, which keeps the oil at a constant temperature throughout the year. Then we moved to the filtration itself. Well, as we've seen from the oil samples we received and analyzed, it was clear that there was an urgent need for supplementary filtration. At first, the client chose for periodic filtration, which is a commonly used technique. Although it's always better to do something than nothing, the downside of periodic filtration is that there's basically only one moment that the oil is really at your target cleanness level, and that's when you just finished filtering the oil. Thereafter, over time, you'll see an exponential buildup of contamination again and wear till the next filtration service is done. In the graph on the left side shows a good representation of this practice. Again, periodic filtration can be a good solution, especially for less critical, low value, easy to exchange equipment. However, for this type of production critical, high value equipment, we really need to look at dedicated or permanent filtration. Therefore, for this application, we chose for permanent offline, also known as kidney loop filtration. It is a low-flow system, creating the ideal conditions for a filter element to be most efficient, and at the same time, making sure it doesn't interfere with the gearbox operation. We also equipped the unit with a very efficient 3-micron element with a beta ratio of 1000 to capture those small particles that are present in millions and millions in the oil. With this type of filtration in place, you ensure that you have constant clean oil, and if there's any sudden contamination ingress, it's captured straight away and doesn't do any additional damage to the internal parts or the oil itself. Remember, always remember that there's no such thing as too clean oil. The cleaner you can keep it, the better. And this also counts for any other oil lubricated equipment. Can you do the next slide, please? The second part of our solution was the monitoring of the oil condition. Note that with oil condition, we refer to two separate but related matters: oil contamination and oil degradation. So let's look first at oil contamination. Well, contamination is basically anything that doesn't belong in oil, where in the industry we mostly talk about the two main contaminant types, being particles such as dirt, sand, wear debris, and humidity, also known as moist or water. Having these in your oil will cause accelerated surface wear on the internal parts of the gearbox, and the longer these are present in the oil, the more damage they will cause. In this application, the client will start taking samples and receiving reports approximately every 6 weeks. We had already come to the conclusion this is not enough. So we looked at how could we increase this frequency. Well, one way would be to take simply more samples. But taking samples every week is a very costly activity, and also not guaranteeing that you will capture any unexpected sudden changes in contamination levels. So the need to be able to measure and monitor the contamination levels in real time was evident. The solution we implemented here was an online contamination monitoring sensor, which we integrated in our filtration solution. We used the pump of the system and installed a manifold block with a pressure compensator called flow control valve to generate the ideal flow for the particle counter to ensure proper and accurate readings. A little bit about the instrument itself. The instrument itself uses a light extinction principle whereby a precision LED light source shines through the fluid and lands on a photodiode. When the particle passes through the beam, it reduces the amount of light received by the diode. And from this changing condition, the size of the particle can be calculated and the amount of the particles can be obtained. In addition to the particles, the sensor was also measuring the percentage of relative humidity, giving a good indication of the water content. Now we have to realize, of course, this sensor doesn't replace a laboratory analysis where you can do several detailed tests like elemental, Cole-Fisher water test, and identify where particle materials, measure additives, etc. But it's really an excellent tool to real-time monitor and trend the oil contamination, as it shows the ISO 4406 class in 4, 6, and 40 micron range. It gives you a particle distribution and also the relative humidity. Also, what you can do with this sensor is set alarms, and as the sensor detects it, the display will change color, and then you can decide to take a manual oil sample and have it analyzed with different tests to understand what's going on with the oil and where the increase of contamination is coming from. So the other matter is the oil degradation. But, well, we have to ask ourselves, what is actually oil degradation? Well, I'll try and give a quick and basic explanation related to this application and based on the graph you see on the left-hand side. Well, basically, a lubricant consists of two parts. It's a base oil and an additive package, where the additives are there to either protect, enhance, suppress, or improve certain physical properties of the lubricant. One of the main additives are the antioxidants, which basically protect the base oil molecules from chemically reacting with the oxygen. So while the oil is in operation and doing what it's supposed to do, mainly reduce friction and avoid metal-to-metal contact, there are chemical reactions going on involving the oil molecules, of which oxidation is one of the main ones. The antioxidants do their job, and the base oil is they do their job. But of course, as these additives are sacrificial, they gradually are being used, and the base oil is being attacked. From these attacks, the oil molecules break down into different molecules. So with other words, the oil degrades or ages. This continues to a point, also marked in yellow in the graph, that the antioxidants are at less than 25% of their remaining life, whereafter the oil is no longer fit for use as it loses its chemical and physical properties very rapidly. So although there are other factors that will accelerate the degradation process, contamination being one of them, typically what we see for this type of application, this process may take years. This particular client was changing the oil for both gearboxes every 3 months, most probably due to high and continuously increased contamination levels. And this is something that we see a lot, time-based or contamination-based oil change. Also, you could say preventative maintenance. But like we've seen before, contaminated oil doesn't mean the oil is also degraded. So if you are able to remove the contamination and maintain it clean and dry, in most cases, the oil is still good for extended use. As our solution to monitor the oil condition or health, we installed an oil quality sensor. The sensor utilizes sophisticated electronics to indicate the current condition of the oil relative to the initial condition of the new oil. As the oil degrades, different chemical reactions take place and causing the molecules to break down into other molecules. And this is what the sensor measures. So it basically measures change of the new oil and the amount of, let's say, different molecules. The data can be visualized in a couple of different ways on the oil quality display. And for this application, we chose to show the condition as a number, where a value of around 850 to 900 indicated that the oil was in good condition. But if the oil doesn't degrade so rapidly, why did we install OQS? Well, the main reason for installing the OQS in this system was to move away from preventative maintenance to condition-based maintenance. So only changing the oil when it's close to its end of life. This means as long as the oil is in the green, you're good to go. If and when it turns yellow, then the alarm goes off and it's time to take a sample and have it analyzed on the chemical level with an FTIR or a ruler test in the laboratory. So far on our solution, I now hand it over to you, Wesley, to talk about a little bit about the implementation of the solution.
Thank you, Martijn. Yeah, I think one of the best parts of this project was actually how much the smelter has teamed up to support our initiative. They really went the extra mile. So what they did was they built custom steel cabinets to house the filtration unit. And I think it was a very good idea because that is going to protect the unit itself from dust, falling debris or material, or any buildup that could interfere with the operation of the machine. So they installed the electrical communications, and when we arrived, we were just focusing on commissioning of the unit, and that's where we stepped in. Sorry, we connected and fully commissioned the filtration unit, ensuring everything ran as it was designed by Desiccant. But we did not stop there. We created a complete, visible and fully monitored contamination control system. We've installed Desiccant isologic breathers for real-time status and protection from the moisture and particles on the main drive gearbox. We then put drain port and breather adapters on these gearboxes, and those were designed or are designed for clean coupling with filtration unit for periodic or, as in this case, a permanent solution. So the drain port adapters that we fitted enabled us to have a dedicated suction line for the offline unit, a manual drain function, and then a high viscosity sample point for quick, safe and uninterrupted oil sampling. The breather adapter then accommodated the breather, both the breather and the return line from the offline unit, keeping everything closed and contamination free. We also installed 3D bullseyes on the small drive gearbox, to make oil level and visual checks possible. Also the oil color, which is very important. And then on the drive gearbox, we installed a smaller breather because it's had a smaller volume. So we added an ACM 61, and that also allowed for protection against water and particle contamination. So together, this created a system that was smart, giving us real-time condition monitoring. It was visible with clear indicators on the screens that were supplied with the sensors, and very importantly, it's easy to service these machines thanks to the user-friendly design. I think most importantly, it's very effective at keeping the contamination under control. I'm going to hand over to Martijn to give you a short description on the Desiccant breather and how it functions.
Yeah, thanks again, Wesley. Another point I wanted to point out regarding those adapter kits, with having these installed, you are really able to manipulate and to do top-offs, to do filtration, to do condition monitoring, to take samples without having to open the gearbox to the environment. And I think that's a really important point, because there's still a lot of gearboxes, maybe the majority, that you have to do a drop tube to get a sample, a proper sample, and of course this then opens up the gearbox to the environment and allows contamination from getting in. Just to complete our balance, let's say, in the contamination control, and as part of achieving a balance between contamination ingress and exclusion, of course, we also had to look at one of the main contaminant ingress points of a gearbox. That's the vent. Basically any oil lubricated equipment has to be able to breathe, either through level fluctuations in the case of a hydraulic system, or temperature fluctuations in the case of a gearbox. So every time the gearbox is breathing, the dirt and the humidity in the environment is being pulled into the headspace. The dirt falls directly into the oil, and at night, when the temperature drops, the humidity forms condensation. These water droplets then also fall in the oil, causing an increase of the relative humidity in the oil. Now, typical OEM breather or vent, as you can see in the picture, the chrome type cap, basically does nothing to avoid this from happening, and therefore an upgrade to protect the asset was really needed. This protection is done by a Desiccant breather. The breathers are installed to work two ways when it comes to humidity. First of all, as the humid air flows through the holes in the bottom of the breather, the silica gel absorbs the moist and thus dries the air before it enters the gearbox. But another thing the breather does is absorbing the moist when the gearbox is breathing out. So in other words, it's basically actively drying the headspace of the gearbox, which, taking Henry's law into account from part 1 webinar, will result in dry oil. And that's in the end, of course, what you want. And by installing a Desiccant breather on the main gearbox, we achieved a relative humidity of 20%, which is approximately equivalent to less than 100 ppms. Well, this is really considered very dry oil in this industry. Besides absorbing the moist, it also has a 3-micron particle, capturing those small dirt particles before they can get in and cause wear and oil degradation. In this specific application, there were 2 gearboxes, the main and the drive gear, and we equipped the main gear with a Isologic smart breather because it actually had some kind of a Desiccant breather when we did the site visit, but you could clearly see that the gel was saturated and it didn't have any particle filter. And what we also saw during that visit, that the drive gear had a typical small gearbox breather. And besides not protecting the lubricant, these small breathers tend to get clogged and or covered with processed dust and dirt very fast. And once this happens, the asset cannot breathe anymore properly and runs the risk of a significant temperature or pressure increase, causing, of course, serious issues. So looking at the solutions we implemented here, so on the small gear, drive gear, we installed a small Desiccant breather with a high dirting and holding capacity. And actually on the main gear, also as requested by the end user, we installed a smart breather. And a smart breather, when we talk about smart, we always refer to data. And this breather actually gives real-time data, not only on the saturation level of the gel, but also tells you if the moisture is coming from the ambient air or if it's coming from the headspace. And this is very valuable data to better understand the condition of the oil. And also note that both breathers were equipped with check valves, ensuring that when there's no air movement through the breather, the gel is sealed off from the environment and does not get used. And this significantly increases the lifetime of the gel. And finally, what we also did, we had a look at the visual oil analysis equipment on the gearboxes. And this is, of course, related to oil level, especially for gearboxes and oil lubricated pumps. The oil level is really essential for the operating reliability of these assets. Unfortunately, most OEMs don't give enough attention to equipment maintainability in the design stage and end up installing a cheap basic side glass, as you can see on the left-hand side. So what happens in practice, as you can see, is that the typical side glass starts to stain or deteriorates over time, making it very difficult to do a proper identification of the oil level. And of course, this imposes an increased risk that too little or no oil is in the gearbox, goes unidentified, and causes a functional, or even worse, a catastrophic failure. And we've seen that happen where in this case it was a pump, but there was a lubricator that had to inspect 50 pumps per day, and in the end, failed to identify if there was if there was oil in one of the pumps, and actually it was the running dry, and they had actually a fire at that plant. So what we did here, we replaced the existing side glass for a 3D Bullseye straight away, and as you can see straight away, it makes a big difference. The visual inspection of the oil level is now easy as it can be, and can be viewed from multiple angles. So over to you, Wes.
Yep, thank you, Martijn. So we want to take you through the system before we did all of the modifications. On this slide, you can see that the gearbox, as it was back then, if you look closely on the tables on the right, showing the left-hand and the right-hand drive gearbox, the problem jumps out. The existing filtration, by looking at the ion levels. So the existing filtration system was not keeping up with reducing the contamination, and in turn, reducing the wear and getting the ion levels lower. The breathers, as Martijn mentioned, that they fitted were inadequate for this operation. Yes, they were desiccant, as you can see, but the desiccant was completely saturated. It's already turned pink, offering no protection from humidity or moisture. And there was no particle element fitted to the breather to exclude dust from getting into the system. So as a result, you could see the elevated ion levels. That's a clear sign of metal generation within the gearbox. But there is a bigger issue at play here when we were doing the investigations. The ion levels were never flagged by the oil analysis reports or the laboratory. Monthly samples were being taken, but because they did not have any set target cleanliness levels or alarms, no corrective action was triggered. So the only maintenance strategy that they had in place was time-based oil changes, which were roughly every 3 months, as we've mentioned. And as we know, changing oil does not fix the root cause of the contamination. This is just a powerful reminder, that we cannot rely on labs to tell us what's good or bad. We need to set cleanliness levels by yourselves or by a subject matter expert who understands the criticality and the operational environment of that specific asset. So when there are no targets, you have no early warning system, and that puts these critical gearboxes under unnecessary risk of failure. So then we can go through what the lab report showed after the upgrades, and you can see, the difference straight away. The iron has almost disappeared. The desiccant breathers, were installed to keep the moisture and the contamination out. The Bullseyes were installed, as Martijn said, for a quick glance of the oil level and the color. And then the breather and drain port adapters, of course, that allowed us for easy connection and, taking the samples. So when we look at the oil analysis results after the upgrade, we see, dramatic reduction in iron levels, and that is proof that wear inside the gearbox has been brought under control. And this is exactly what an effective contamination control modification or upgrade is supposed to do. It's to protect your equipment. You want to extend your lubricant life, and of course, you want to reduce unplanned maintenance costs. So with this solution, we had a smart, clean, and reliable system, exactly what these critical gearboxes like these are looking for. I think it's time for another poll. So the next question, quite interesting. We know lots of people do, and we know lots of people don't, but do you monitor your oil cleanliness levels today? Yeah, that's quite interesting. We have 66% says yes by manual sampling, 16% yes with sensors, which is great, and 16% not applicable. That is typically what we see happening in our industry and here in South Africa. Good. Over to the next one. So this is actually the part that we love sharing. You know, proof is in the pudding. When we first started the machines up, the cleanliness of this gearbox was an ISO code 232219 on the 320 PAO. So we asked one of the artisans to keep an eye on things, you know, over the next few days using the contamination monitoring sensor and the oil quality sensor. And they've reported just after 2 days, there was a significant reduction in particles. It went from 23, 22, 19 to 16, 14, 11, which is a massive improvement. And by day 7, we were down to 15, 13, 10. And then came the real kicker. So a few months in, they had to replace the filter element. You know, everything's been stabilized and the oil had circulated through the system thoroughly. And that's when we saw a remarkable drop in cleanliness down to an ISO code 1075. And this is for gear oils, which is extremely, extremely good. Then basically the results. This is also very exciting for us. The gearbox, as Martin said, you know, historically they experienced a 15-year life out of these gearboxes. And by the time we started the project, you know, the gearboxes were already 7 years in. But by achieving this type of oil cleanliness levels that we just spoke about, we didn't just protect them. We've effectively extended the expected lifespan of these gearboxes by 2 to 2.5 times. So instead of performing expensive time-based oil changes every shut or every 3 months, they now make decisions based on real-time quality data from the sensors. So that means there's no more guesswork, no more wasted oil, just data-driven, proactive maintenance, you know, that keeps the gearboxes running reliably while reducing the cost and the downtime. I will let Martin talk a little bit about the financials.
Yeah, thanks, Wesley. Well, although I'm not a financial guy, but these numbers are quite evident that made a really big difference. So we've now technically solved the issues of the gearboxes and have implemented the solution. And well, talking a little bit about numbers and how the cleanness level oil is directly and indirectly connected to the maintenance cost of the main gearbox. And before I go into a little bit more detail on the numbers, please remember that the numbers are showing only savings on the gearbox, not considering even higher cost on the costly downtimes, on the oil changes, of the loss of production, of the manual labor to replace these gearboxes, etc., etc. So, having that said, looking at the before situation, well, so before our implementing the solution, the gearbox was running on a highly contaminated oil, and the previous gearbox was actually failed after 15 years, while the design life, as we've seen before, was actually 30 years. So, but considering these 15 years and the cost of a new gearbox of $270,000, the write-off cost per year of a gearbox life is $18,000. And well, on the right-hand side, after implementing our solution, we had a complete new situation. The gearbox runs very smooth on a very clean oil. So therefore, we were able to increase the relative remaining life with at least a factor of 2.5, probably even more. But there's no need to consider the cost of a new gearbox because it will not fill anymore. So not applicable. So the write-off cost of the gearbox per year is reduced by half to $9,000. Now, considering the cost of our solution, complete solution being $13,000, the savings are over a period of 5 years, only on the gearbox, looking at this gearbox, $35,000 with a payback time of only 17 months. So this ends up being an internal rate of return of more than 200%. So really, if you look at that number, I think it's really a no-brainer to start upgrading more gearboxes in that plant. Well, again, besides the direct savings on the gearbox, there was also another significant saving, and it's almost equal to the savings we had with the gearbox, which was actually on the unnecessary oil changes. Because as we've seen before, the oil used was quite expensive synthetic oil, which cost approximately $2,780 per drum. And each drum was divided over 2 gearboxes. But considering they were changing the oil time-based every 3 months, they are now saving, in the first year, they're already saving more than $11,000. So this already is a return on investment, of the solution just by saving on the oil changes. And of course, this also, again, is not accounting for all the associated costs, like disposing the used oil, etc. Well, besides these savings, the cost savings, money-wise, there were also numerous additional benefits, such as reduction of the maintenance labor cost, the plant safety improvements, and others. So all in all, really quite impressive data. Having this said, I think we have another poll question coming up on the ROI. And thank you, Fran, for that. So the question here is, what drives the buy-in when presenting the ROI to your management? I'm not sure if I can see. Yeah, we're seeing some answers coming in. Nice to see. Yeah, a reduced maintenance labor costs. Yeah. And of course, this comes together with the maintenance cost itself. Yeah. And yeah, also a strong one is a lower cost per failure, of course, and equipment life extension. Yeah, nice to see. So that brings us to the takeaways. Sorry, Wes.
Yeah, I was just about to say the same thing. So, what's the big takeaway from this success story?
Yeah, well, if you ask me, it's that when we have the right partners and the right technology, and you're willing to dig it deeper into your clients' issues and problems, you can completely transfer lubrication management.
Exactly. We didn't just install the filtration unit. We proved measurable improvements are possible. Clean oil, healthy gearbox, and ultimately lowering the operational costs.
Yeah, true. And that's huge because now the plant is using data-driven oil changes instead of just doing them on the schedule. And we've already seen how much money they're saving. So no more wasting good oil and no more guessing.
Yeah. But to also be clear, you can't just rely on the lab to tell you when to act on issues. You need to set your own cleanliness target levels or work with a subject matter expert, to get the baseline and strive towards precision lubrication.
Absolutely. And I will also would highly recommend that if you are involved in lubrication and you take samples and you bring them to the lab, please try to understand the lab results yourself. Not looking at the traffic light, which is often in the right-hand corner, but really looking at the data of that report, and also evaluate which type of analysis you want to see and you want to have done. Because if you leave it up to the lab, they will do just the very standard stuff. And also remember, there's no such thing as too clean oil. Really, dedicated filtration, also especially for critical gearboxes, is really worth the money and the time.
Yeah, and this type of upgrades, drives down maintenance costs and improves reliability. But this can be implemented in any industry with any oil lubricated piece of equipment.
Absolutely. We have projects in whenever it's mining or manufacturing, power generation, cement, you name it. If it has oil and oil lubricated equipment, we come across very dramatic situations, and it's all about keeping that oil clean and dry, and with that your operation runs smoother. You have less maintenance cost, of course, and less downtime. And also, we didn't really touch that, but if your machines are able to run smoother and more reliable, you will see that your energy costs are also significantly reduced. And all in all, this helps also with the plants striving to get more sustainable operation running.
Yeah.
Well,
Great.
Thank you, Martijn and Wesley, for taking the time today and sharing with us the details of the success story. And thank you, obviously, to Stephen and his team at Filtration Management Solutions for working with us and their customer to allow us to showcase this success in their mining plant. We did get some questions in. We have a few more minutes, so I will start just reading out some questions. If you have more, please submit them. If we don't get to your questions, we definitely will reach out afterwards to get you an answer. So one of the questions that was submitted was, what was the consumption of filter elements with 3 micron size in such dusty and rough environment?
Yeah, very good question. So as per one of the previous slides, we managed to get a cleanliness improvement of quite a bit from a 23 to a 16. I think the first set of filters ran for just short of 2 months, and then it blocked up. And I think the main reason being is, we suck in the oil from the very bottom of the lubricant of the gearbox. So we're getting all the sediment and all the debris that was in the gearbox before the installation going through the filters. Luckily, they do have a large dirt holding capacity. I think it's 230 grams. So we managed to the first filter change out will obviously be very quick, but as time goes on, the filter consumption goes down because you're maintaining those cleanliness levels and excluding the contaminants.
Great, thank you. And then another question is, how serious of a problem can it be for a gearbox if a standard breather becomes blocked, and what type of failures usually occur, and are the consequences the same for smaller and larger gearboxes if the breather is blocked?
Martijn, do you want to go for that one?
Yeah, sure. So yeah, what can happen is that the gearbox cannot breathe anymore, so you get temperature buildup. And as the temperature increases, what happens to the viscosity of the oil? The oil will decrease. So it will have direct influence on the film thickness and film strength, causing basically higher friction and potentially metal to metal contact, so wear. So that's one of the the issues that can occur. There's also another issue, that's pressure buildup, and I think Wesley, maybe you can comment a little bit on what you have seen quite recently.
Yeah, so we were at another facility where we wanted to take an oil sample. It was also a sinter plant, and the guys actually, tried to open up the plug on the side of the gearbox. I could see that the guy was struggling to open it up, but he eventually managed to get it open. And as he tried to unscrew that plug, it actually shot out of the gearbox. So I think it's not only a risk on safety, pressure buildup, but also it could impact your seals. If there's a pressure buildup, gearboxes are not supposed to have pressure in, especially the non-circulating types.
Another question was, is there any recommendation apart from the manufacturers, if they exist, on what the optimal oil cleanliness level should be for gearboxes intended for different applications?
Yeah, I think Mark covered that in the previous webinar. I think it was at an 18, 16, 13 as an industry standard, I think. But some gearbox manufacturers do give you the cleanliness levels. They would typically tell you this is the maximum limit at an 18, 16, 13, but keep in mind that that's the maximum limit. We need to strive to be cleaner than that to extend the life of that gearbox even further.
Mm-hmm. And then I know that unit had a heater, so I think somebody missed, why did we install a heater with the unit? Was that due to very low temperatures in winter? Just to clarify.
Yes, correct. So what happened is that this particular gearbox, especially the main gearbox, was turning very slow. So it was, the temperature of the oil was really kind of dependent on the ambient temperature. And that was fluctuating between what I understood around 10 to 30 degrees. And we installed a heater just to, let's say, smooth that out, have a constant temperature of the oil, and which of course also helps to increase the lubricity of the lubricant and the filterability.
And I think we have time for one or two more questions. What percentages of gearbox failure can be directly linked to oil cleanliness issues?
Yeah, I think quite a bit. If 70% of loss of usefulness is related to wear and 80% of that is because of particle contamination, then I think the number is quite high. So I think it's quite a high number. If it's not misalignment or obsolescence, it's particle contamination or lack of lubricant. But I think that's majority is particle contamination.
Yes. Just going back to the clogged filter, somebody was like, how many assumptions did we make over the 5-year period of how many breathers would be used in filter elements as an exchange to get to that ROI?
So I think that was factored in on the amount of filters that were changed in, I think, a 3 or 4 month period. And in that time, we did not have to change any filter breathers. The breathers were still good to go. But in the meantime, the plant is actually shut down and is probably only going to start back up next year. So we can continue monitoring and looking at the filtration costs going forward. But typically, we try and size breathers to last 6 months. And yeah, the filters, I think, would probably last 3 to 4 months, depending on the ingress. And if the guys are, actually maintaining the breathers.
Thank you. Any last minute add-on with Tyne or Wesley before we close out? Okay. Well, thank you so much for presenting today, for sharing, and then thank you everybody for joining us for the part 2 in this webinar series. As I mentioned before, a recorded version of this webinar will be available later, and I also will include in the follow-up emails a success story for you to read through it again and see those numbers that were accomplished. We really appreciate you joining, and check for updates on the website for more webinars to come. I hope everybody has a great rest of their day. Thank you.